Hello students, from the year 2025-26 academic year, the syllabus has changed for BSc Math students, and here is your syllabus. In Sem1 you have differential equations instead of differential and integral calculus. So our new syllabus is differential equations, and in this here you have 4 units. In first unit, first topic is differential equation of first order first degree. In this, first of all, we need to know some introduction of differential equations. Let us see. Here differential equation means an equation involving independent variables and dependent variables and its derivatives. See here. Suppose we are taking this equation. Here we have y is dependent variable, and this is depends on x, which is called independent variable, and it involves the derivatives. So this total is nothing but differential equation. So an equation involving independent variable, dependent variable and its derivatives, total is nothing but differential equation. So we can use in differential equation either one independent variable or more than one independent variable, but the dependent variables only one, and independent variables means either one or more than one. Suppose here we are taking one dependent, one independent, then that type of differential is said to be ordinary differential equation. And we are having more than one independent variables, then we can say it is a partial differential equation. So ordinary means with respect to single independent variable, which is known as ordinary. Example, this one. We are taking normal derivatives. In this case, only we have one dependent and one independent. Whereas in partial, it has more than one independent variable. So see here, partial derivatives are denoted by dou. So we are taking partial derivatives as dou square z by dou x square or dou z by dou x, whatever it is. So here we have z is dependent variable here, and here we have two independent variables. So like these are called partial differential equations. Now order of a differential equation in the sense highest order, highest derivative, nth derivative is the highest derivative, then we can say order is n. That means when you are taking one differential equation, then how many times you are differentiating here? Here how many times we are differentiating? 2 times, d square y by dx square. That's why order is 2. Here how many times we are differentiating? Highest one is 2. That's why 2. Here how many times we are differentiating? 4th time derivative. That's why the order is 4. Right? Similarly, degree of a differential equation in the sense highest power of higher order derivatives. That is nothing but this. In this case here, this is the higher order. What is the power of this? 3. Then this 3 is nothing but the degree of the differential equation. But in degree, you have some conditions to find the degree. So say here, degree does not exist for logarithm and trigonometric functions of derivatives. That means log of derivative, sine of derivative, log x is given, you can find the degree. But log of derivatives are given in first order or second order, whatever it is. Log of derivatives or trigonometric functions of derivatives are given. In that case, degree does not exist. See here, in this question, what is the highest order? Second derivative we are doing, so order is 2. And what is the highest power of this? 3. Here highest power is 8, but what we should take is take the highest order. That power is nothing but the degree. That's why here degree is 3. Similarly, here order. What is the highest order? Here only one time we are differentiating, so obviously order is 1. But here log of derivatives are given, so degree does not exist. Right? In the same way, here order is 2 here, and what is the power of this one? 1. And it is independent of radicals, like log of derivative was not given. That's why power of this is 1. That's why degree is 1. And in this degree, to find the degree, we have another rule, that is power should not be in p by q form, that is should not be in fraction or decimal. That means suppose one question, differential equation is given to find the degree. Here it is a fraction. In this case we cannot find the degree directly. It should be free from radical, in the sense we should remove this fraction by taking here by 3 is given, so cubing on both sides. Then what will happen? Here cube, here cube. Then 3 gets cancelled here, here 2. Now we are checking for order. What is the order here? Second order derivative. So this is order is 2, and whose power is what? 3. And here there is no fraction in the power. So what is the degree for this? 3. And see girls, here also it is having fraction. That's why squaring on both sides, then by 2 will be eliminated. So y square here eliminated, here whole square. Now check for the order. What is the order here? Second order derivative. So order is 2, that power is 2. So degree is 2. Now here is one topic, linear differential equation. A differential equation is said to be linear if it should have a first degree. Okay, so for it is of first degree, then we can say it is a linear differential equation. So when whatever the order will be there, suppose d square y by dx square, but degree is here not 1, so it is not the linear differential equation. So degree is 1, then only we can say it is linear differential equation. And general form of linear differential equation is dy by dx plus py equal to q, where we are taking here p and q are either constants or only functions in x. That means suppose instead of p and q you can take sin x, log x, e power x, or 2, 3, whatever it is, but it should not contain y. It only contains x or constants. And here see, observe here order is 1, that power is 1, so degree is 1, in the sense it is linear differential equation. And non-linear differential equation means degree is not equal to 1, that is it is not linear, then it is non-linear, that is nothing but degree is not equal to 1. Now ordinary differential equation of first order first degree means order is 1 and degree is also 1, then it is in the form like dy by dx should be there, and we are adding any function in x and y, which is called what? First order first degree differential equation form. Now we are representing first order first degree in another form also, that is what? M dx plus n dy equal to 0, where m and n are functions in x and y. See, observe here, when you are taking divided by dx, what will happen here? 1 will come. Here dy by dx. Dy by dx is nothing but what? Order 1, degree 1, which is called what? First order first degree differential equation. So here any first order first degree differential equation is given to check whether it is an exact differential equation or not. Then we need to satisfy some condition. What is that condition? Dou m by dou y equal to dou n by dou x. Partial differentiation of m with respect to y is equal to partial differentiation of n with respect to x. Then we can say the given differential equation is exact differential equation. Suppose this condition has proved, then the solution of the given exact differential equation is integration m dx. When you are taking integration m dx, then take the y as constant for m term. In the m term, y should be taken as constant, and plus integration n into dy. In this n, we should not take x terms. So not having x terms, we should take for n equal to some constant. This is the solution for exact differential equation. So what is the condition for exact? This one. And what is the solution for exact? This one. Now one question here is, so see here, this question, some function in xy into dx plus some function in xy into dy equal to 0. It is of which form? Obviously m dx plus n dy equal to 0. Now for this form, what we need to do first? Find the value of m. Dx coefficient is m, dy coefficient is n here. Now dou m by dou y equal to this dou m by dou y. Dou m by dou y means partial differentiation with respect to y we are doing means x and y are two independent variables, right? Here m is a function. In this case, with respect to y we are doing, then take x as constant. With respect to x we are doing, then y as constant. Now see here, dou m by dou y in the sense dou by dou y of this one. Now when you are taking y means x should be constant, so take the constant as it is. Now y square derivative is what? 2y. Now x derivative with respect to y means it is a constant, so obviously 0. So 2xy plus 0 is nothing but 2xy. Similarly, n, dou n by dou x with respect to x we are doing means y constant, take it as it is. X square derivative is 2y plus y with respect to x means constant, so it is 0. So these two are equal in the sense dou m by dou y equal to dou n by dou x. So which is said to be an exact differential equation. In this case, what is the solution? Integration m into dx. So take m, what is m here? This one, into dx, where y as constant, and we are taking n here where not having x terms. So in this, when you are taking integration y constant in the sense, see, y square is constant, so constant y square as it is. Integration x into dx is nothing but x square by 2. Similarly, integration x into dx is nothing but x square by 2. See here, not having x terms. So in the first term it has x, so we should not take this term. Here it is not having x term. That's why integration y into dy only we have to take. So see, integration y into dy equal to c. Now here integration x is x square by 2. Similarly for second term, integration y means y square by 2 equal to c. Take 2 LCM and take it into this side. So instead of 2c, we can take this as c1 suppose. Then 2c1 we are taking as c. Then we are taking x square y square plus x square plus y square equal to c, which is nothing but the required solution of the given exact differential equation. Similarly, we can see another problem. See, m dx plus n dy equal to 0 here. So take m here, n here, and take derivative with respect to y, partial differentiation. Then what will happen? Let us see. With respect to y, we are doing means cos x is constant. So constant into function means take the constant as it is, and function derivative. Here e power y derivative is e power y plus constant derivative is 0. E power y plus 0 is nothing but e power y here. Similarly, dou n by dou x means with respect to x means which one is constant here? E power y constant as it is. Sin x derivative is cos x. Now both values are equal in the sense it is exact differential equation and the solution is same as it is. And now substitute m and n values here and see here. M take it as it is, take y as constant of course, and whereas in m not having x terms, here in n we have only one term, it contains x. So we should not take, there is no term which is not having x. That's why simply we can write here 0 into dy. Now y as constant means this is constant. Integration of constant into function means constant, take it as it is, and integration of cos x into sin x is nothing but sin. Integration cos x into dx is nothing but sin x. So e power y plus 1 sin x plus here 0 constant, integration of 0 is 0 of course equal to c. So here is the solution of given exact differential equation, and tomorrow I'll continue the same method problems. Thanks for watching.